Hello, continuing our series looking into TMUA, the entrance exam papers, and this question is from um, 2017 paper 1, and we're looking at question 7. This says the first three terms of an arithmetic progression or sequence are p, q, and p squared respectively, where p is less than 0. Let's keep a note of that. It says less than 0. Also, the first three terms of a geometric progression or sequence are p, p squared, and q. So we've got some connection between these two progressions in terms of p and q. And it says find the sum of the first 10 terms of the arithmetic progression. So then when we found whatever the connection is between p and q, we can go back to the arithmetic and work out the first 10 terms. So what do we know about arithmetic sequences? We know the difference between consecutive terms is always the same. It's a common difference. So the difference between the first and the second is the same as the difference between the second and the third. So the second is q minus the first, which is p, equals the third minus the second. So we can rewrite that maybe as something like 2q equals p squared plus p. And then for a geometric progression, the connection between each pair of terms is that the ratio is the same, the common ratio. So the second divided by the first must be the third divided by the second, q divided by p squared. So we can rewrite that as p cubed equals q. So now we've got a connection. Basically we've got two simultaneous equations. We can solve for p and q. So let's do that. Let's substitute for q in the first one. So we get 2p cubed equals p squared plus p. We can rearrange this. We can take a p out. So we get 2p squared minus p minus 1 equals 0. Clearly p is less than 0, so we can ignore that p straight away, cancel that. And then we can factorize 2p and p, 1 and 1. We want minus p in the middle, so we want minus there plus there. Then we note that p is negative, so we take the negative solution of this, which is the p equals minus a half. And then we can consider, we now got an answer for p. Q is p cubed, so q equals minus a half cubed, which is minus an eighth. So we've got our two values for p and q. And we want to work out, well, let's write down the first three terms of the arithmetic progression. The first three terms are p, which is minus a half. And then the second one is q, which is minus an eighth. And the third, which is p squared, which is plus a quarter. So we can see by looking at these three terms, it's arithmetic, so there must be a common difference. Minus 8 up to a quarter, that's 2 eighths, plus another 8 is 3 eighths. 3 eighths, does that make sense? Minus 4 eighths plus 3 eighths is minus 1 eighth, so that's correct. The common difference is 3 eighths. So now we need to remember the formula for the sum of the first n terms, which is Sn equals n over 2 brackets 2a plus n minus 1 times the difference. And in this case, we've got S10. S10 equals n over 2. Well, that's 5. 2 times minus a half is minus 1. N minus 1. N is 10. So this is plus 9 lots of the difference. The difference is 3/8. So this equals 5 lots of 9 times 3 is 27 over 8 minus 1. Well, that's 8 over 8. So 27 minus 8 is 19. 5 times 19 over 8 equals, well, half of 19 is 90. Of 18 is 90, plus another 5 is 95. So I get 95 over 8. Let's double check to see if that's in the list, and sure enough, it's here. And that's the answer to the question.